it's cooling. So when you finish a weld, you finish it here and there's a post flow, which means how long the gas keeps flowing after you let off the gas. You want to hold your hand there. So you know how usually when you finish welding, your hand, you never do that with TIG. So you finish and you hold it there and you count to 7 to 10. I usually count to 7. So you 1, 2, 3. And listen for the gas to stop. If you don't hear the gas stop because all the other noise, just count to 7. And what that does is allow your weld to finish, and it also allows that gas to keep purging on your weld. So you want to make sure you wait for that. So when we usually sharpen your tungsten, which you'll be doing a lot, you simply push this back inside the hole, point side out. And then what I usually call it is whatever you can pinch. So whatever minimum I can pinch right here is how much tungsten I want out. So it usually ends up being about 1/4. Okay. Then you just tighten it up and then that's stuck there. That's ready to weld. So the next page is going to show you torch and rod angles. And this is the way you hold the torch, by the way. You hold it like a pencil. Put one finger here and the rest rests on your hand here, and this gives you complete control of everything. And I'll show you the filler rod's only about 20 degrees. So that's why I said I put it in my finger like a pencil, then I'll lay my hand down on the metal where I'm going to dip it. That way I can keep that small angle, right? Just like the picture shows you. And then I'll get my puddle going and then I'll tap it and move at the same time. And it's your ground clamps on your work or it's on your table. That's why you usually weld on a metal table. You can ground the table and then anything you set on top of it is then also grounded. If you're working on something bigger that can't be on a table, you have to put the ground right into what you're working on.
With stick welding, I've always heard the ground closest to the work as possible is the same with the TIG.
Yeah, it is. It's the same.
Helps the conductivity, whatever that.
Yeah, it just makes it a better ground source. Okay, let's go to bead initiation. We'll skip some of the other ones there. This just kind of shows you a general look of what a bead looks like. When you start a weld, it actually forms a little crater. Okay, and the way welding works is you dig and fill. So whenever the energy is in the metal, it's actually digging a little puddle out, and then you're actually filling it with the rod. Okay, so it usually looks like a small wave. You have your filler metal, and then you have the little spot where the energy is digging. It's not as pronounced on a TIG as in other processes, but it's still there. You'll notice if you start at a spot and turn it off, it'll have a small little crater in it. So bead formation, they're showing you a weld. Two things. The first weld is just moving and adding puddles. The other one is actually doing like a weave, which is trying to weld a bigger area. So when you're dropping metal on and you're moving it with the torch, dropping metal, moving it with the torch. That's if you're covering a wider area. So like if I'm welding that pipe I was telling you about, I got to put a cap on it, and the cap's maybe a 1/2 inch wide. I'm actually going to take the energy and paint. This is your paint brush. I'm going to paint that weld this way. I'm going to add a little metal, move it, add metal, move it. Okay? I'll show you that.
You're talking about filling a gap in like you would with a stick. Rod in there, bring it out.
But normally with TIG welding, especially on stainless or anything like that, it's going to be straight, no movement at all, and dipping over. It's usually very small weld. Bead termination, when you stop welding, you used to do like a small circular motion, and you do the same thing with the rod to fill in that crater. Okay, so that's just terminating when you want to stop. You don't want a crater in it. You just stir a little bit extra metal in there to let off, and that'll fill it. Okay, a lot of this stuff is just a cross section of a fillet weld. We'll talk about this stuff later. And this stuff you can read at home. I want to get back to the back here. There's definitions of direct current, constant current power source. And in the very back, I gave you a section for Miller. This is my favorite part. And I believe on the last page of your book, you check on the very back, because they're right there. See all those websites?
Yeah.
I left a bunch of websites on there for you guys to check out on the very last page. Miller is probably one of the most progressive educational companies that there is. When you go on their site, this says, how do I TIG weld? It's actually a computer animation of what welding looks like, and it's something that's so hard for me to explain. They do such a good job at it. I'd recommend everyone go there tonight and check it out. I mean, it's just a great computer animation of what it looks like. And it's really hard to show you. Even when you look at it when I weld, the weld is so small, you guys have a hard time seeing it. So it'll be easier when you're sitting here, 4 inches from the weld.
Not only that, I've been to their website. They actually have like videos for like every machine they do.
Yeah, they're great. They're a great resource. So check that out. And then I printed all these out. So if you ever decide to do more TIG welding it shows you what position for the different types of joints. So, it used to be plain with stainless. Different kind of joints. The very first one they show you is a butt joint. And a butt joint is simply butting two pieces of metal together. That's all it is, okay? And it shows you what angle to have your torch at and where to put your filler rod in. It shows you straight in line, maybe a little bit off, but 20 degrees, right? The next page, it's going to show you a lap weld. And a lap weld is just like it sounds, it's overlapping. So you take a piece of metal and you lap weld, like that. It shows you your torch angle is a little bit different, right? Your torch is kicked into the angle just a little bit, and your rod's still at 20 degrees. When you're talking about a T-joint, which is called a fillet weld also, it's this joint right here. Okay? That's called a T-joint. You use that a lot when you're building things. It shows you now, you'll notice that your torch is no longer straight up and down. Now you're kicked into your angle a little bit. So if you're sitting like this,
So you just have
you're
to
going to
like
be kicked
split
into
the
your
angle.
angle a little bit. More pointing at the bottom, not directly into the angle, a little bit at the bottom, because if you think about the way the heat's going to go, it's going to travel like a chimney, right? This piece here is going to get hotter than the bottom piece. So the reason they show you the angle right there for doing a fillet weld, you'll notice it's pointed more at the bottom plate than the plate coming up, because the heat will automatically come up this like a chimney. If you point it directly in the corner, you'll burn a hole through this plate.
It'll pull back like that way.
It'll start to burn it up on this side. So you got to put more energy there, and then the reflection will get this hot enough to turn it liquid. And then a corner joint. A corner joint would be like if you built a box, and it'd be doing the outside corner. One of the cool things about TIG welding is you can make it like this and burn that autogenously and have a very beautiful outside corner with no rod whatsoever. You just take the two outside edges and fold them in on top of each other. It makes a nice round corner. Really nice. I'll show it to you guys.
You said with no rod?
No rod. On this thing.
Stainless.
Yeah.
It's like a sewing machine or something if it's done right.
Pretty sweet. Pretty sweet. Okay, then some other things I put in there is just to show you what kind of tungsten to get. They're all different color coded. Green is pure tungsten. The only time you use pure tungsten is on the older coil type machine. Like these machines here, you have to use that for aluminum and magnesium. That's the only time you use pure tungsten. Otherwise,